One Well, The Story of Water on Earth, written by Rochelle Strauss and illustrated by Rosemary Woods. One well. Imagine for a moment that all the water on Earth came as just from one well. This isn't as strange as it sounds. All water on Earth is connected, so there really is just one source of water, one global well from which we draw all our water. Every ocean wave, every lake, stream, and underground river, every raindrop and snowflake, and every bit of ice and glaciers and polar ice caps is part of the global well. So whether you are turning on a faucet in North America, pulling water from a well in Kenya, or bathing in a river in India, it is all the same water. And because it is all connected, how we treat the water in the well will affect every species on the planet, including us, now and for years to come. Earth is the only planet that has liquid water, and therefore is the only planet that can support life. You need water, and so does everything else. Every person, every plant, and every animal. Without water, nothing can survive. The amount of water on Earth hasn't ever changed. It has been the same for billions of years. The water in the well. We live on a watery planet. Almost 70% of Earth's surface is covered with water. This surface water is found in oceans, lakes, rivers, streams, marshes, even puddles and the morning dew. There is so much water that if you looked down at Earth from space, it would appear blue. But there is also water we can't see, beneath the Earth's surface. This groundwater can be found just about everywhere. It fills the cracks in the rocks and the spaces between the rocks, grains of sand and soil. Most groundwater is close to the Earth's surface, but some of it is buried quite deep. The water is also frozen in glaciers and polar ice caps, and there is that water in the atmosphere. Every one of these water sources feeds Earth's one well. Where is the water on Earth? Oceans contain 97.23%. Ice caps and glaciers, 2.14%. Groundwater, 0.61%. Freshwater lake, 0.09%. Inland saltwater seas, 0.08%. Moisture in the soil, 0.005%. Water in the atmosphere, 1/1000%. And rivers, 1/10,000%. Yes, there is more water in the atmosphere and soil than in all of the Earth's rivers. Recycling water in the well. The water you drank today may have rained down on the Amazon rainforest 5 years ago. 100 years ago, it may have been steam escaping a teapot in India. 10,000 years ago, it may have flowed in an underground river. 100,000 years ago, it may have been frozen solid in a glacier. And 100 million years ago, it may have quenched the thirst of a dinosaur. The amount of water on Earth doesn't change. There is no more water now than when the dinosaurs walked the Earth. The same water just keeps going through a cycle over and over again. This constant movement of water is called the water cycle. During the water cycle, water evaporates from the oceans, lakes, rivers, ponds, and puddles, even from plants and animals. It rises into the air as water vapor. As water vapor rises, it cools into tiny water droplets. This is called condensation. These droplets form clouds. Gradually, clouds collect more and more water droplets. The average white cloud weighs about twice as much as a blue whale. When the water droplets get too heavy, they fall from the clouds in the form of hail, snow, or rain. This precipitation returns to oceans, lakes, and rivers. It also seeps into the soil and down into the groundwater. Year after year, water continuously circulates through the water cycle. One year, an area of rainforest the size of a football field pumps over 75,000 liters, that's about 19,700 U.S. gallons, of water vapor into the atmosphere, more than enough to fill a backyard swimming pool. It takes about 1 million tiny water droplets to make just one raindrop. Why are the oceans so salty? Rivers flow into the sea, collecting salt from the rocks and soil and adding it to the ocean. As the ocean water evaporates, the salt is left behind. How thirsty is a tree? On a summer's day, an average-sized birch tree can draw about 300 liters, about 80 U.S. gallons, of water from the soil. That's almost enough water to fill 2 large bathtubs. Many plants and animals depend on water to disperse their seeds. A coconut, the seed of a palm tree, can spend weeks, months, or even years drifting in the ocean before reaching land and sprouting. The plants you eat are mostly water. Tomatoes are about 95% water. Apples are about 85% water. Seeds are among the driest foods. They contain only 5 to 10% water. The first plants on Earth began life in water. About 450 million years ago, some were washed ashore. At first, they could only live in wet areas. Gradually, they developed root systems that allowed them to tap into water in the soil. Water is essential to plants. In fact, plants are mostly water. It's the water in their cells that give them their shape and form. Without it, they droop and shrivel. Water also helps plants make food for themselves. Plants use the sun's energy to change water and carbon dioxide into simple sugars that feed the plant. This process is called photosynthesis. Water then helps carry the food throughout the plant. During photosynthesis, plants also release water vapor into the air. Roots absorb water, which is carried to the stem. The stem acts like a water pipe in your house, moving water through the plant to the leaves. From the leaves, water is released back into the atmosphere. This is called transpiration. The water that is transpired is added to the cycle of water on Earth. Water is important to plants, but plants are important to water. Plant roots anchor soil and stop it from blowing or washing into lakes and rivers. Leaves and branches trap rainwater, allowing it to seep slowly into the soil instead of flowing quickly away. And trees provide shade, which helps keep moisture in the soil. Plants depend on the water from the well for survival, and the well depends on the plants to help move water through its cycle. Without plants, the water cycle would be disrupted. Without water, plants could not survive. Animals at the well. Like plants, animals, including you, are mostly made of water. The water in the animals is very important. It carries nutrients, helps digestion, removes waste, controls temperature, cleans eyes, and lubricates or oils joints. Water habitats are also home to many of the Earth's animals and are where many animals find their food. Watery species such as fish, crabs, shrimp, and zooplankton are an important part of food chains around the world. A food chain is the link that connects animals and other species based on who eats whom. Without water-based species, food chains and food webs, collisions of food chains, would collapse. Animals would starve. Animals not only need water to survive, they are also part of the water cycle. Animals add water to the atmosphere by breathing, sweating, peeing, and even drooling. The water you brushed your teeth with today may have been a spray of beluga whale 10 years ago. Some of the wettest animals on Earth are jellyfish. They are about 95% water. Frogs and earthworms are about 80% water, while dogs, elephants, and humans are about 70% water. All animals need water to drink, even desert animals. They get much of their water they need from the food that they eat. Animal life began in the ocean. Then about 360 million years ago, some of the animals started to evolve. Their animal bodies began to change, and they slowly adapted to living on land. Saltwater marshes are wetlands that occur where the land meets the sea. These habitats are homes to a wide diversity of species, from microscopic bacteria, fungi, and algae to fish, crustaceans, reptiles, birds, and mammals.
She's not busy.
Some rainforest frogs, insects, spiders, and worms and bacteria live their entire lives in tiny pools of water that get trapped by the leaves of the biomedial plant. How can fish live in frozen lakes? Waters freeze from the top down, but it rarely freezes right through. The ice at the surface is like a blanket that keeps the water below from freezing. Coral reefs are found in warm, shallow waters of the ocean. They have been described as rainforests of the sea because they are home to incredible diversity of species. Watery habitats. A habitat is a place where an animal can find everything it needs to live: food, shelter, space, and water. Water is such an important part of an animal's habitat that there isn't enough available. The animal will move away even if all of its needs are met. Most animals depend entirely on watery places, such as oceans, lakes, and wetlands, for their habitats. Freshwater habitats, lakes, rivers, and streams, are home to about 12% of all of the animal species in the world. Saltwater habitats, oceans, seas, and some saltwater lakes, are home to 60% of all fish species, as well as many other species, including some mammals and reptiles, such as whales, turtles, and sea snakes. Some of these animals live their whole lives in water and wouldn't survive out of it. Others, such as frogs, toads, and many insects, spend part of their lives in the water and part on land. Whether water is their habitat or just part of their habitat, animals could not survive without it. Since the beginning of time, people have depended on water for drinking, for food, for bathing, and for watering their crops. Water has always provided a highway to move people and products from place to place. As cities and societies grow, so does their need for water. Today, water is essential in our homes, in industry, and in agriculture. At home, we use water for cleaning, cooking, drinking, flushing toilets, and for bathing. But homes only account for about 10% of all fresh water used. About 21% of the water we use goes to making everything from computers to cars. Water is used in hydroelectric plants to generate electricity and in petroleum plants to make gas. In factories, water is used to heat things up or to cool things down and to wash away waste. Water vapor, steam, even runs machinery. Water is also an ingredient in many products such as lotions, shampoos, chemicals, and drinks. The remaining 69% of the fresh water we use goes into agriculture. Farms use huge amounts of water for crops and livestock. Look around. Almost everything you see was made using water. It took about 130 liters, 34 United States gallons of water to make your bike. Water was used to grow and make the food you eat and the clothes you wear. Water was even used to make the paper for this book and the ink used to print the words. It takes about 185 liters, 49 gallons of water to produce just one glass of milk. This includes the water the cow drinks, the water used to grow food for the cow, and the water needed to process the milk. About 147,000 liters, or 38,800 gallons of water was needed to make your family's car. In North American homes, the bathroom is where about 3/4 of where all water is used. One flush of the toilet uses nearly 13 liters, 3.5 gallons. A lot of water is required to produce the food you eat. Approximately 5,200 liters, or 1,375 gallons of water is needed to make just one fast food lunch: burger, fries, and a soda. Nearly 1 billion people around the world depend on fish as their primary source of protein. Thirsty? People drink an average of 2.5 liters, 2/3 of a gallon of water a day. In your lifetime, you will drink the equivalent of a backyard swimming pool full of water. Lake Baikal in southeast Siberia contains almost 1/5 of all the fresh water on Earth. It's also home to the Baikal seal, one of the world's few freshwater seals. The Bering Glacier in Alaska is the largest glacier in North America. It's about 5 times bigger than New York City and nearly twice as tall as the Empire State Building. Approximately 1/1000% of all water on Earth is in the atmosphere. If a tanker truck represents all the water on Earth, the water in the atmosphere would barely fill 1/3 of a pop can. Around the world, more than half of the drinking water we use comes from underground aquifers, layers of gravel, porous, holy rocks, or soil that has trapped large amounts of water. Fresh water in the well. Though we live on a watery planet, not all of that water can be used to meet our needs. That's because we as humans and many other species depend on fresh water, and supplies of fresh water are limited. Most of the water on Earth is salt water, almost 97%. Only 3% is fresh water. If a tanker truck filled with water represented all the water on Earth, then the water used to fill a large bathtub would represent all of the planet's fresh water. But most of the fresh water, over 99%, is frozen in ice caps and glaciers, trapped deep underground or in the atmosphere so that we can't use it. How much fresh water is available to us? Remember that bathtub? Imagine filling 9 pop cans from it. This represents all the fresh water we can use. While there is a lot of fresh water on the planet, we have access to less than 1% of it. Some families are lucky. They can turn on the tap for drinking water, to fill a bathtub, wash their cars, or water their garden. But other families around the world are less fortunate. 1 billion people, almost 16% of the Earth's population, have to walk more than 15 minutes to get to the nearest water supply. There, they gather water for the day, just a few jugs, barely enough for drinking, cooking, and cleaning. Other families don't have access to enough water to meet even those basic needs. While the amount of water on Earth is always the same, the distribution of water across the world is not. Huge differences in rainfall can happen from country to country and even within the same country. Less rainfall means less water available in lakes, rivers, and aquifers. Sometimes there just isn't enough water where it's needed most. Because water is not evenly distributed across the globe, nearly 1/5 of the world's population does not have access to enough water. Many of these people live in Africa and Asia. A bucket of water weighs about 10 kilograms, 22 pounds. Imagine if you had to carry a bucket or 2 from a well to your house every day. North America has 1/3 of the population of Africa, yet North Americans use 3 times as much water. How is this possible? Nearly 300 million people in Africa do not have access to enough fresh water. This chart shows you the place average daily water use per person. 1 bucket basically equals 10 liters or 2.6 US gallons. You'll notice that in North America has 55 buckets, Russia 27.5 buckets, Poland 14 buckets, India 7 buckets, Nepal 3 buckets, Haiti 1.5 buckets, and Ethiopia 1 bucket. China and India are home to over 1/3 of the world's population, yet they only have access to 1/10 of the world's fresh water. By 2025, many experts predict that 1 out of every 4 people will live in a country that is short of water. By 2050, 4 billion people may be living without enough clean water. We need more water for more crops and livestock in order to feed the Earth's growing population. Every day, all the world's livestock, cattle, sheep, pigs, goats, chickens, drink the equivalent of more than 160,000 large tanker trucks full of water. The demands on the well. $6,563,107,901, give or take a few. That's how many people there are on Earth, and that number is growing every day. More people mean a greater demand for water. But this growing population isn't the only thing putting a strain on our water supplies. The average person today uses about 6 times more water than 100 years ago. A growing population also means we need more space. As towns and cities grow to accommodate all these people, they gobble up land, which also affects nearby water. Houses, buildings, and roads sometimes take the place of wetland habitats where animals live, which puts species at risk. They also change the way rainwater, lakes, and streams flow. The pavement and concrete block rainwater from refilling groundwater supplies. There are more of us, and our demand for water at home, in industry and in agriculture, has grown tremendously. But all the water we have is all the water we will ever have. There is no more water now than there was 100 or 1,000 or even 10,000 years ago. And there will be no more 100 years from now, when the population may be closer to 10 billion. We need to find a balance between our demands for water and the amount of water that's available to us. Pollution in the well. The water cycle helps keep the Earth's water clean. As water evaporates, minerals, chemicals, and dirt are left behind. The water vapor that rises into the atmosphere is relatively clean. When rain falls back to the earth, some of it is filtered through rocks and sand and further cleaned. Even plants play a role. As the water travels through them, plants remove chemicals in the water. Then they transpire clean water back into the air. But more and more waste from industry, agriculture, and homes is getting into the water. Runoff from backyards, city streets, and farm dumps dirt and chemicals such as pesticides, fertilizers, and detergents into lakes, rivers, streams, and ponds. Pollution in the atmosphere from cars and factories mixes with the water vapor in the air. The rain that falls pollutes surface water and groundwater. Our actions may be overloading water's natural ability to clean itself. As more water becomes polluted, there is less clean water available. Nearly 80% of all sickness in the world is caused by unsafe water, and wildlife suffers too. Water pollution threatens the health of many species of habitats across the planet. Because of water's self-cleansing powers, the effects of pollution can be stopped and quite possibly reversed, but to do so, we need to reduce the amount of pollution that gets into the water. Water dissolves more things than any other liquid. So in nature, water is never really pure. It almost always has something dissolved in it. Every day, 1.8 million tons, 2 million regular tons, of garbage are dumped into Earth's water, enough to fill more than 15,000 train boxcars. Wetlands are nature's water treatment plants. They absorb chemicals and filter out pollution and waste. When pollution in the air mixes with rain, it can turn into acid rain or even acid snow. This acid precipitation can fall thousands of kilometers or miles from the source of the pollution, even reaching remote areas such as the Arctic. Saving the water in the well. Water has the power to change everything. A single splash can sprout a seed, quench a thirst, provide a habitat, generate energy, and sustain life. It also has the power to unite or divide the world. Water is the most basic, important need of all life on Earth. But Earth's one well is in trouble. There is simply not enough clean water to go around. Taking actions to conserve water can help save the well. Conserving water means protecting both the quantity and quality of water on Earth. For example, using less water helps prevent water sources from drying up, and reducing water pollution protects the overall health of the well. Water conservation can help ensure there is enough clean water for everyone on the planet. By becoming more aware of how you use water and by using less, you too can protect the water in Earth's one well. Remember, every drop counts. Becoming well aware. Water conservation isn't just something for governments, corporations, and environmental groups to think about. Everyone needs to get involved in water conservation, even you. And it's not hard to do. It doesn't just mean living without water. It just means becoming well aware of every splash of water we use. By reducing your water use, you too can become well aware. Even the simplest actions can make a huge difference. Imagine all the water you could save just by keeping drinking water in the fridge instead of letting the tap run until you get cool water. And by making sure you turn off all faucets so that they don't drip. You can save up to 10,000 liters, 2,650 gallons of water every year. But becoming well aware doesn't just mean using less water, it also means taking better care of the water we have. You can protect the water from pollution.
Junior high baseball, you're excused at this time to get ready for the bus. It leaves at 3:15.
You can protect the water from pollution by walking more and driving less, which keeps car exhaust from polluting the water in the atmosphere. Organizing shoreline cleanups keeps trash from entering the lakes, rivers, and streams. Planting trees anchors the soil so that it doesn't wash away into the waterways and make them muddy. Imagine what would happen if each of us did just one thing to conserve water and protect Earth's one well. These actions would add up. Together, they would help ensure that there is enough clean water now and for years to come. Here are just a few ways you can become well aware. Learn more and educate others. By learning more about Earth's one well, you can make choices in your life that help you to conserve and protect water. Then share what you learn. Help the people around you become well aware too. Join others. There are many organizations working to protect the water or helping people to get the water they need. Find out more about organizations that interest you and support their work by raising money, volunteering your time, or helping you spread their message, or start your own campaign. Conserve water. With your family, explore all the ways that you use water and then brainstorm some ways to reduce your water use at home. Some suggestions include turning off the water while scrubbing your hands or brushing your teeth, running the dishwasher and washing your washing machine when only full, asking your parents to fix leaky faucets, collecting rainwater to water the plants in your garden or house, watering your lawn only when it needs it and only early in the morning or evening when less water will evaporate. And protect our water. Rainwater can wash waste and pollutants into storm sewers, which flow into local rivers or lakes. Oil, grease, salt from roads, fertilizers, and pesticides from gardens, paint, oil, leaves, and litter can all end up in local waterways. Many communities paint fish or other symbols near sewers to remind people that sewers empty into waterways. Does your community have such a program? If not, why not try to start one? Improving access on one well at a time. More and more children and their families are becoming well aware. Some, like Ryan Herzlak, are helping to make water more accessible to those who are in need it most. In 1998, as a 6-year-old, Ryan learned that many people in Africa didn't have access to clean water. He raised enough money to build a well near a school in Uganda, but he didn't stop there. With his parents' help, he started the Ryan's Well Foundation, which continues to raise money to build wells in Africa and educate people elsewhere about the need to conserve water. The rest of this is just notes to parents, guardians, and teachers, and I'm not going to finish reading that. I hope you enjoyed the story.